And thus we begin our talk of negative exponents. This can be a tricky topic if you're not clear about what's a factor and what's a term. We're going to talk about this distinction many times over the next few weeks and next few months. Factors imply multiplication. They are things that are being multiplied or divided. Terms are monomials that are being added and subtracted. It's really important to have this distinction because, well, let's just kind of launch into this. Negative exponents. So 4 to the negative 2. Here's what we kind of make sense with negative exponents. If I have 2 squared, that is 4. If I have 2 to the 3rd power, that is 8. 2 to the 4th power is 16. 2 to the 1st power is 2. So if I follow this pattern of 16 divided by 2 is 8, divided by 4, divided by 2, divided by 2. If I keep dividing by 2 to go left, I establish meaning for 2 to the 0. 2 to the 0 power is 1. This is true about anything to the 0 power. We keep going to the left and we establish what 2 to the negative 1 means. 2 to the negative 1 is 1 over 2. 2 to the negative 2 is 1 over 4. 2 to the negative 3 is 1 over 8. And if you kind of look at this pattern, 1/8, 1/4, 1/2, 1, 2, 4, 8, 16. You keep multiplying by 2 to go from the left to the right, and you keep dividing by 2 to go from the right to the left. What I'd like you to do right now is, well, I'm trying to look for space here. I don't have a lot of space, so and I don't want you to make it take out a new piece of paper. Let's just kind of go up here in the margin on the right. 2 facts to remember. And by remember, I mean review this at some point so you can remember this. A to the 0. Any base raised to the 0 power is equal to 1. This is kind of weird, but anything to the 0 power is equal to 1. There is one exception to that. A cannot be equal to 0. 0 to the 0 power is undefined. The second thing is that A to the negative n is equal to 1 over A to the n. This has some significant consequences. Like if I have 1 over A to the negative n, that is equal to A to the positive n. If we look at calculators, and this is an important one to do, take a minute, really, pull out your calculator. If I type something in like 1 divided by 9 and press enter, it's going to give me 1/9. I think yours does too. And I want you to see that if I type in 9 raised to the negative 1 power, that also gives me 1/9. Those two are the same thing. 1 over a number and 9 to the negative 1, or that number to the negative 1, are the same thing. This actually leads to the concept that raising to the negative 1, x to the negative 1, is the reciprocal of x. So I'm going to circle these 5 things, or 4 things. This is 1, 2, 3, and 4. And I'm going to keep those kind of off to the side while we go through this. Number 1, 4 to the negative 2. Let's just first deal with the negative part and make that 1 over 4 to the 2 power. Because we said a negative exponent means flip, means 1 over. So 4 to the negative 2 is 1 over 4 squared. Or 1/16. Okay, next, let's go 12 to the 0 power. 12 to the 0 power follows this rule right here. Anything to the 0 power is equal to 1. So that's going to be 1. Negative 12 to the negative 12 to the 0 power. We're going to follow order of operations here and raise to the exponent first. Negative 12 to the 0 power is 1, but this is still a negative 1 out in front. So I'm going to rewrite this actually. This is negative 1 times negative 12 to the 0 power, which is negative 1 times 1, which is negative 1. Number 4, if we follow that, this is 2 to the negative 1, which is 1 over 2, times, and 4 squared is 16. 1/2 times 16 is 8. Negative 7 to the negative 2, your base is negative 7, so we're going to flip and make that 1 over negative 7 to the second power. That's the same thing as 1 over 49. Negative 5 to the negative 4 is the same thing as negative 1 times 5 to the negative 4. That 5 to the negative 4 is going to flip and go to the denominator and become negative 1 times 1 over 5 to the 4th, which is the same thing as negative 1 times 1 over 625, or negative 1 over 625. The next one, 5 minus 2 to the 4th, or 5 minus 2 to the negative 4th, we're going to follow the order of operations. Deal with that first. 3 to the negative 4th, which is the same thing as 1 over 3 to the 4th, or 1 over 81. Number 8, do not add 3 plus 3 to get 6. You would be breaking order of operations. 3 to the negative 1 is the same thing as 1/3, so this is 3 plus 1/3. 3 plus 1/3 is the same thing as 3 and 1/3, or we can think about adding those with the least common denominator. The least common denominator, if we change that, that would be 9, or sorry, that'd be 3, which we multiply by 3 over 3 to get 9/3. Think about it this way, we're just going to take the 3 and make that 9/3 plus 1/3, and gives us 10/3. Number 9, same idea. This is 1 over 2 squared plus 4, or 1/4 plus 4. Let's think about this one this way. That's really 4 and 1/4, which is the same thing as 17/4. 3 to the 0 is 1. 1 to the negative 4. 1 to the negative 4 is 1. 3/4 to the negative 1. That's the same thing. Well, let me kind of back up here before I do this. Remember the negative 1, if we go back up to what that meant over here on the right side, I think I was muffled then, I'm sorry, but x to the negative 1 is the reciprocal of x. Anything to the negative 1 is its own reciprocal. What that means is if I kind of look at 3/4 and say 1 over 3/4, that's just the same thing as 4/3 to the first power. So another way to deal with that exponent is just to make reciprocal. And if you look back up, that's exactly what we've been doing every time we have a negative exponent. 4/3 to the 1 is just 4/3. Let's make that a better 3. Number 12, 2 to the third power is 8. So I'm going to make that 8 over, and this is the first case that we have of what sometimes we affectionately refer to as popcorn. Yes, the food, popcorn. We're going to take 2 to the negative 2 and move it up to the numerator, keeping a 1 in the denominator, but by moving it up we make that exponent positive. This is now 2 squared. How can we do that? Because the reciprocal basically changes what's in a denominator to a numerator and vice versa. What's the reciprocal of 4/3? 3/4. Numerator becomes denominator, denominator becomes numerator. By moving the 2 to the negative 2 up, we eliminate the negative exponent. It's now a positive exponent because it's in a different spot. 8 times 2 to the 2nd. We also can ignore that 1 now in the denominator. It's just 8 times 4, and 8 times 4 is 32. Number 13, we're going to do the other way around. This is going to move down as 2 to the positive 2 times 5 to the 2. 2 squared is 4, 5 squared is 25, and we have 1 over 100. Okay, misconception alert. Sometimes people will move that down, but they'll move it down and keep the negative. That's incorrect. When you move places, it has to become positive. Another misconception alert. Suddenly now you may think that we can take the negative 4 and move it down, but that's not the same thing. The negative is not an exponent there. Only when the negative number is an exponent, or a power, can we move it around. Number 14, we don't want to flip-flop or do popcorn twice. What we want to do is go back to the rule of number 3. Sorry, we called it rule number 3. So if I go rule number 3, this is the power of powers, which says that when we raise an exponent to another exponent, we multiply the exponents. 2 to the negative 2 to the negative 2 is 2 to the negative 2 times negative 2. Negative 2 times negative 2 is 4. 2 to the 4th is 16. Let's go to 15. Now we're going to have to kind of set some strategy here. Let's do order of operations. Negative 3 to the third power is negative 27. 3 squared is 9, and that is all to the negative 2. Negative 27 over 9 can simplify to negative 3. Negative 3 to the negative 2 is the same thing as 1 over negative 3 to the positive 2. Negative 3 to the positive 2 is positive 9. Number 16. I see a negative and I get confused. So what we do is we break it up. Let's remind ourselves that a negative a is really a negative 1 times a to the negative 2. That a to the negative 2 now can be expressed as 1 over a squared. And then it becomes very clear what we can do with the negative. It's just a negative 1 over a squared. R to the negative fifth is just 1 over r to the positive fifth. That's done. 18. This is really a 6 times an x to the negative 3 times a y to the second. The middle one here is a negative exponent, and that is going to move downstairs, keeping us a 6y squared over x to the positive 3. By moving the x to the negative 3 to the denominator, it becomes positive exponent. Number 19. 6 to the negative, or k to the negative 6th is 1 over k to the 6th. K to the negative 1 is 1 over k. And if we multiply across, this is 1 over k to the 7th power. Notice also we could have done our adding exponents, made that k to the negative 7, and then gone that way. Number 20. I am now going to set a strategy of drawing a fraction bar. And I'm going to read left to right and say, what is the exponent? Sometimes it actually helps to go through and fill your exponents in. That's 14 to the positive 1. That's 3 to the positive 1. Those stay on top. 14, x to the negative 4 goes down as x to the 4. Y to the negative 3 goes down as y to the 3. The 3 to the 1 stays on top. The x to the 5th stays on top. The y to the negative 3 goes down as a y to the 3rd. And now we collect our terms, or our factors. Sorry, these are not terms, these are factors. 14 times 3 is 42. X to the 5th over x to the 4th, y to the 6th. Finally, we look to see if we can cancel anything. Yes, we can cancel an x to the 5th over x to the 4th and make that an x. 42x over y to the 6th. 21, we have 3 to the negative 3. I'm carrying the exponent across. Don't call it distribute. Let's just carry it across. 3 to the negative 3 and u to the positive 9th. Now we can start worrying about what to flip, and the only thing that flips is the 3 to the negative 3. The u to the 9th stays on top. Oops. And now we're in the denominator, 3 to the 3rd. So u to the 9th over 27. 3 to the 3rd is 27. It is not 9. 22, I can do a couple of things here. First of all, I can cross out the x to the 0 because that's just equal to 1. Don't worry about that. Now the 2 remains. That's 2 to the negative 4th, y to the positive 12th. The power of powers rule. 2 to the negative 4th goes down to the denominator. The y to the 12th stays on top. So it's 2 to the 4th. Then I have y to the 12th over 16. Number 23, we're going to carry the negative 3 exponent across. 3 to the negative 3, z to the positive 6. Then I have 9, z to the negative 3. We could do a few things here, but let's just try to make this a little bit easier on us. Let's flip-flop things between the numerator and the denominator. So I'm going to draw a fraction bar and read left to right. 3 to the negative 3 goes down. It's 3 to the 3. Z to the 6 stays up. The 9 stays up. And the z to the 3rd goes to the denominator. The z to the 6th and the z to the 3rd cancel to become z to the 3rd in the numerator. And the 9 and the 3 to the 3rd power, remember 3 to the 3rd power is really 27. So 27 divided by 9, that's going to give us a 3 in the denominator. 24, we have a negative 3. It's negative 3 to the negative 2. R to the positive 4, R to the negative 3. Let's do the same thing, fraction bar. we've got r to the fourth, negative 3 to the second in the denominator, and r to the third in the denominator. Our r's cancel, and our negative 3 to the second becomes a positive 9, r over 9. 26 is special. It's the first one that's going to try to confuse you between what stays in the numerator and what flip-flops to the denominator. The only thing with the negative exponent is that x to the negative fourth. Everything else is going to stay exactly where it is, including the negative 5. That negative is a coefficient. It is not an exponent. So the x to the fourth, and then we have another x to the fourth from the one that moved. Cancel the 5 and the 10, and I get 2 over a negative 1. Actually, I get 2 over negative x to the 8th. We can leave it like that, or we can express it just kind of more generally as negative 2 over x to the 8th. Number 26, I see an s to the 0, and we're going to cross that out because s to the 0 is 1. I see 27 and 6. I'm going to cancel those and get a 9 and a 2. And then I'm going to start moving stuff around. The 9 stays on top. The t to the second goes on the bottom. Now read the bottom. The 2 stays on the bottom. The s to the second moves to the top. And the t to the fourth moves to the stays in the denominator. Shuffle them around and rewrite it a little bit. I've got a 9 s to the second over 2 t to the sixth, and nothing cancels. 27, simplify this expression. We're just going to flip-flop the stuff around a little bit. Let's draw a fraction bar. 7 to the negative 1 moves to the denominator as 7 to the 1. 2 to the negative fifth moves to the numerator as 2 to the positive fifth. 2 to the fifth is 32 over 7. Then this one says rewrite this expression without negative exponents. That just means take this thing and move it down. So I have 4 to the third over 4 to the seventh, and then I move down to 4 to the fifth, which is 4 to the third over 4 to the 12th, and if I simplify, that is 1 over 4 to the ninth. And let's leave it like that. 4 to the ninth is messy. 27 says to simplify this one. So let's move some stuff around by drawing a fraction bar and reading left to right in the numerator. Take 3 to the negative 1, move it down. A to the negative 2, and move it down. 3 to the second stays down. And a to the negative fourth moves up. Positive exponents stay where they are. Negative exponents switch spots. A to the fourth cancels with a to the second, giving us an a to the second in the numerator. And our 3's combine to form a 3 to the third. And 3 to the third is, of course, 27. Finally, find the value of 2 times 3 to the 1, or negative 1, plus 4 times 2 to the negative 1. This is just an order of operations problem. Let's do 2 times 3 to the negative 1, which is the same thing as 2 times 1/3, plus, this would be 4 times 1/2. 2 times 1/3 is 2/3. 4 times 1/2 is 2. So 2 and 2/3, which is the same thing as 2 times 3 plus 2, is 8/3. These are some answers just to check that we did this correctly. I believe we did. And your homework is listed on the calendar, but for our purposes, because you want to see what it is right now, here it is. Freeze, pause, see you later.